So here's the electric car problem. And like I said, the first strategy I want you to use is to read the question and then go back and draw the class hierarchy, right? And then go back and label each class with its methods and any instance fields that it has, right? So when I first read this question, I'm thinking, okay, it has classes. That means there's a class hierarchy, right? So I would get confused if I didn't draw out the class hierarchy. And once I do draw it out, I'd realize there's only one class, a battery charger class. I'd also realize that there are these two methods here, and these two methods are the ones that they want us to implement, right? The ones that they want us to define. So, in my mind's eye, it would go from being a more complex problem to, after drawing the class hierarchy, it would become clear that it's a less complex of a problem. Um, and I just want you to use these strategies as we're going through these free response questions. And at the end of it all, you decide if you want to continue using it when you take the exam. But with me, just go ahead and follow my lead, right? And what is this problem? Well, we have this electric car that needs to be charged for a certain amount of days, and he has a rate table that is a single digit array that contains these values, right? With the zero element having a 50 in there, the 14th element, or the element with the index of 14 having the value 220 in there. So this is basically how much we need to charge. I'm sorry, how much it's going to cost if we charge during that hour. So if we charge from 22 to 23, then the cost is going to be $60 or 60 units, whatever, 60 cents. Right. And so if we go ahead and read through this, we could see here that we do have a start hour that we're given, right here, and get charging cost. And we're also given a charge time. Okay. And if we read through these preconditions, postconditions, basically the preconditions are givens. What you can assume, right? Preconditions for the method, right? So you take that as a given. And then there also might be a post condition, and that's also a given following the execution of the method. And so the first task is to write the battery charger method get charging cost, right? So we got this one here. And so how does that work? You get a starting hour and a charge time, and you figure out how much it's going to cost if you are given those two pieces of data. So if our starting time is 10 and our charge time is 5, we would need to add 200, right? Because that's 1 hour. And then we would need to add 40 because that's 2 hours. Then we would need a increment by 240, and that's 3 hours. We would need increment by 220, that's 4 hours, and then we would need increment by 220 again, and that's the fifth hour, right? Because we start at 10 and the charge time is 5, so that's 1, 2, 3, 4, 5. Right? So one thing to note is that we could have a start time of 10, and we can also have a charge time of 36, right? And if that's the case, then we would need to increment, 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 right? And then when we're at 11 o'clock, which is 23, then we would go here to 24, increment, 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 right? So for those of us who have taken the Intro to Coding class, this is a pretty easy or obvious application of the modulo operator. Right? And modulo, of course, gives you the remainder. So if we take the starting time and we are incrementing it, right, by the charge time, eventually it's going to become a number that's bigger than 23. Right? But if we take that expression and we mod by 24, then it's going to be 10, 11, and so on. It's going to be 21, 22, 23. We get to 24, and we're modding 24 by 24, which gets us to 0. Right? So by modding by 24, it'll keep us within this range of 0 to 23. All right, so let's go ahead and look at the solution here, right? So we have two different solutions. There's one here and then there's one down here. This one here uses the mod operator, and it's pretty straightforward. We have our cost is our counting variable. We set that equal to 0 because our cost is 0 in the very beginning. We haven't started any calculations. Right? We have our start hour coming in as a parameter, and we have a charge time coming in as a parameter. Let's assume this guy is 1, this is 5. We come into our for loop and we start our index variable here at start hour. So we start that at 1, right? And then we say while that hour variable is less than the start hour plus the charge time, right? Keep on iterating, okay? As long as this condition is true. And then we want to increment hour. Right? And then notice here there are no brackets, right? But if our body is simply one line of code, then the brackets are optional, right? It's not until the body becomes more than one line of code that you must have brackets in place, okay? So just something to keep in mind. And as we're coming through, what are we doing? We're incrementing cost by what's in the rate table, right? With an index of the start hour, right? Modded by the rate table's length. Right? Rate table is the array, and the length of that array is 24. Right? So that idea of what I was talking about earlier is that we want to mod by 24. Right? Okay. And so if we put in the number 24 here, if we hard coded it in, I believe that would still get us our full points here. Because this table is not going to be changing over the course of the running of the program. Right? So don't worry if you put a 24 in here, that should be fine as well. And then once that for loop iterates, right, it will have the cost of how much it costs to charge at that start hour using that charge time. Right? And then we return that cost because, of course, this method returns an int. Right? And that's what we calculated. Right? And now we have the next. Oh, this is a different method. So if you were, doing this problem and you're like, oh, I don't even know modulo exists. Well, here's another way you could have done it, right? And this is a way that I saw a couple students doing it. And so what are we doing here? We have our index is going to be our start hour, right? So this is 1, and then we're incrementing cost by 1, right? And we're incrementing the 1 to 2, but we're also checking. Right? So if our index increments to 24, right, the length of the rate table, then we reset our index back to 0. Right? And then we have our hours remaining decremented to make sure our while loop iterates the correct number of times. But this little bit of Java Kung Fu right here acts as modulo acts, right? It would reset the index back to 0 when it reaches 24, when it reaches 48, and when it reaches 72, I believe, right? And then at the end of it all, we're going to return the cost, the same as we did up here. So get charging costs, right? Pretty straightforward. Now, what's the next problem is that we want to get the get charge start time, right? And if you read through this, the way that works is the get charge start time should be the lowest cost, right? So the start time, if you're given where is it? Okay, so here's the signature. You're given a charge time, right? And this method should give you back the hour that you should start at in order to get the lowest dollar amount that you need to, or the lowest cost. Right? So if we're looking at this chart here, right, and we had a charge time of 5 hours, right? Well, I think just by looking at it, 23 would be a good place to start. Or I'm sorry, 22 would be a good place to start, right? Because it'd be like 1, 2, 3, 4, 5, right? And that set of numbers looks like the lowest set of numbers that are on this chart. Right? And then if you look at it even further, you might be thinking, well, all of it should always just return 22 because because that should always be the lowest place to start when we're charging, right? Um, and so that's a false assumption, because what if we have 22, right? And we have a charge time, well, we're starting at 22, and we have a charge time of 23 hours, right? Oh, I'm sorry. Well, let me just leave it at this. Okay, I don't think I'm equipped to explain that like at the moment, but that's an assumption, and it's safer to be absolutely correct in your algorithm than to just assume that, right? Um, and not only that, but that assumption is wrong, and that would lead to a 0 on that portion of the AP exam, right? The free response question. So, what's the best way to, or the absolute way to find the cheapest starting point? Well, the way to find the cheapest is to start here at 0 and then run the charge time, right? Say it's 5, go 1, 2, 3, 4, 5, add up all those values, right? And then treat this as a min-max algorithm, right? Where here you're trying to find the minimum of a set of values, right? So that first set of 5 would be the first value that you're considering is the minimum, right? So that would become the minimum. And then we're going to set our start time to 1, run the same thing, right? So we're going to go 5 spaces down. So 1, 2, 3, 4, 5. We're adding up all of these costs and we're checking, is that the minimum, right? Compared to what our current minimum is. And then we would just work our way through iterating 24 times, right? So we're basically just calculating every possible cost and then we're finding the minimum of them all. And if you haven't taken, a prerequisite course for this class, min-max algorithms are fairly simple, but very alien when you have never thought about them before, right? And how does a min-max algorithm look? It goes something like this. So if we have like an array of size 10, and they're all filled with different values, what you're going to do is you're going to have an integer min be equal to a very low number, right? And then we're going to have a for loop that's going to iterate 10 times. And in the for loop, you are going to have an if statement, and you're going to say if min is less than, if r sub I is less than min, then min is equal to r sub I. Okay.
Okay.
And Kita, I gotta finish this video, baby. Can you go outside? You wanna say hi to my class? Say hi.
Okay.
Say hi.
Hi.
Say hi. My name is Kita.
Hi.
My name is Kita.
My name is Kita.
And I'm a little cutie.
I'm a cutie.
All right, go outside, baby. All right, and so this is the min algorithm, right? And it would work because this is going to be true on the first iteration of this for loop, because whatever value r sub 0 is, it's going to be, it's going to be greater than, it's going to be less than, hold on a second. No, this guy should be a really big number. Okay, it's going to be whatever value of r sub 0, it's going to be less than min, because we set min to some huge number, right? And so min is going to be equal to r sub 0. And then we're going to iterate through, and it's going to compare the next element in the array to what was in r sub 0, right? And if that next element is less than min, then we're going to set the new minimum to that next element in r sub 1, right? Maybe this is not as obvious as I thought it was in my mind, but if we had these numbers here, and we run through this algorithm, we have r sub 0, which is 3. Is that less than 99999? Yes, this is a true statement. So min is equal to 3. Okay, so our min is currently 3, and then we iterate through, and r sub 1, which is 8, is less than 3. That's not true, right? We iterate again, r sub 2 is less than 3. That's not true. So we iterate again, we iterate again, we iterate again. And when it's equal to 2, well, 2 is less than 3, our current minimum, right? So this is a true statement. And now minimum is going to be equal to 2, right? And then it's going to go through 12, but this is not a true statement with 12, and so it's going to break out of the for loop. And when it breaks out of the for loop, what's min going to be equal to? It's going to be equal to 2, which is the minimum of all these values. All right, so that's the minimum algorithm, just a classic algorithm, right? Just like finding even and odd, there's just like a set of like 20 algorithms that are, just classic algorithms that you go over, and they're a mystery when you don't know about them, but then once someone explains it to you, it's something that you never forget, right? So we're going to use that here in our get start time, right? So what are we doing? We have our charge time. We have the cheapest start hour. We start him at 0. We set our start hour equal to 1, and we go less than the length of the table, so this is going to be less than 24, and then we increment our start hour. Right? So then we can assume that get charging cost works, right? So we can just use it. And how are we going to use it? We're going to say if get charging cost of start hour of 1 to the charge time is less than the get charging cost of cheapest start hour, that's 0, and the charge time. If that's true, then the cheapest start hour is going to be equal to this start hour here. Right? And then it's going to iterate through all of, and this for loop here, the body doesn't need any brackets because the body consists of a single if statement. Right? And then this if statement doesn't need any brackets because the body of this if statement consists of a single statement. Right? So this all would compile and it would be legit. But of course, I would not want you playing around with this if you're not comfortable, just because it might confuse you, right? So always put brackets if you're not comfortable and you're kind of thinking, should I put brackets? Should I not put brackets? Always put brackets if that's the case, right? But if you're more comfortable, of course, that's the way it goes, right? So this would compile fine. But yeah, basically you're just comparing the previous start time, right? The total cost of the previous start time charging a certain number of hours to the next hour's accumulation of the start time to the. I'm sorry, the this is confusing, hard to say. But yeah, we're basically comparing the charge time starting at 0 to the charge time starting at 1, right? Or I'm sorry, the cost to charge starting at the 0 hour to that cost starting at the 1 hour, right? And yeah, and we're just doing a min algorithm here, right? We're just checking if it's less than the cheapest start hour, which is a 0 element, right? Which we can assume is the starting cheapest hour because it's the first cheapest hour, right? And yeah, so there's different ways to code this, implement this, but this is basically what you're going to be having in your answer, right? And then at the end of it, you return the one with the cheapest cost, right? The start hour with the cheapest cost. And that's about it. Sorry for the video being so long, but YouTube has a double speed functionality, which I hope you're using with my videos.